Hi guys. All right, can you guys see me and hear me? Awesome.
Yes, ma'am.
Wonderful. Thank you guys. I am doing okay. I hope everybody else is doing okay also. I'm trying to figure out how I can do my online office hours outside since the weather is so amazing today, but I don't think it's really gonna happen. So I'll be at my computer from 3 to 4. But yeah, I hope you guys are all doing well. We are going to cover some ground today. Of course, we'll start as always with a little brain teaser, which you guys can look and be thinking about while I'm talking. I have a bunch of administrative stuff to cover with you guys today, mostly related to the exam and the exam rollout. And then we will talk about just two concepts from chapter 3 that will be on the exam. And that should do it for today. So let's go ahead and get started warming everybody up to something that we began talking about last time, and I asked you guys to review the posted slides for last time. So what the goal is here, not to name the entire molecule, but only based on this question, to find the main chain in each molecule and give just the main chain its name. So go ahead and take a minute, look at these two molecules, poke at your screen to count your numbers, count your carbons, and see if you can find the longest chain here. Okay, we've got a vote for octane on the left and nonane on the right. Do you guys agree with that? All right, well, let's see if we're right. So let's go with the one on the left first, and let's number the carbons. So if we number here, 1, 2, 3, oh, we've got a competing vote. So now we've got an octane and decane. So we've got octane and nonane or octane and decane. So let's start just with the one on the left and number our carbons. So 1, 2, 3, 4, 5. What do we do from here after carbon 5? We go down because that's the longest chain. So that is indeed 8 carbons here, and that is indeed an octane. Okay, and it looks like you guys are coming to a consensus in the chat box that the one on the right is actually 10 carbons, and that is correct. So we can start either with this carbon or with this carbon, it does not matter. And if we number our carbons, 4, 5, 6, 7, 8, and then from here, if we go in this direction where the OH is, we only have 9 carbons because there's no carbon here, there's an oxygen. But if we go in this direction, we get out to 10 carbons. So indeed, this molecule on the right has 10 carbons. So you got an octane on the left and a decane on the right. Okay, so I just picked a direction for numbering these things. Take a moment and look at the direction that these are numbered. So we went left to right, but we could have also gone right to left. We could have gone right to left over here. So take a moment and for yourselves, think about whether we've gone in the right direction or do we need to reverse that? What do you guys think? Are we good in the direction that we're going for both molecules? We got 1 vote for reversing. So let's go through this together. We'll talk about these more in all of the slides, but the directionality of the numbers should go so that the very first substituent that you run into is on the lowest number of carbons. So what do I mean by that? Well, on the molecule on the left, we have a bromine and an ethyl group as substituents. And if we number the way it's numbered, the very first one will pop up on carbon 2. But if we number in the opposite direction, 1, 2, 3, 4, if we are going this way, then our very first substituent would be on 4. So the red numbering here is correct, and the green numbering is bad. What about on the right? Turns out those are fine also, because we have a substituent at carbon 2 and carbon 8. And if we went in reverse, this would be carbon 3. So it's better to have it at carbon 2. Okay, and we'll see some more examples of these as we go through the slides for nomenclature together. So, to get on to the announcements and administrative side of things, we are going to keep going with chapter 3 today. And just as a reminder, I do have office hours this afternoon using the Zoom link. They're online office hours this afternoon. And also as a reminder, you have 2 more SI sessions before your exam. There's one today at 5 p.m. that's live and in person. And there's one on Thursday at 12:30 p.m. Via a Zoom link. So that's tomorrow via Zoom. So just a couple of kind of bookkeeping things, make sure everybody's on the same page. You guys have a couple of graded assignments that are open and pending for you right now. The first is a quiz on the chapter 2 material that I currently have the deadline set to be today at midnight. So as a reminder, we talked about this on Monday. This quiz is not really a real quiz in the sense that it is open book and there's no time limit on it, but it must be representative of your own work. You can't work with other people in the class or out of the class on this quiz. It is under the assignments tab, and you will need the Respondus browser to take this quiz. The goal here, part of the goal here is to make sure that everybody has a chance to test the Respondus browser, make sure it's working for them on their computer or their device before we get into the time window for exam 1. The other goals here is that I think this quiz is going to help you guys practice and study for exam 1. It'll give you a sense of the types of questions that I might be asking on chapter 2. And my hope also is that it'll give you guys a chance to boost your quiz grades if you're unhappy with how you did on chapter 1 quiz, or if you just want some buffer for the future. Here's my advice to you guys. My advice to you guys, because this is an open book, no time limit quiz, my advice to you is do as much studying as you can for chapter 2, and then open the quiz and take it as if it's a real assessment, that you don't use your book, you don't take forever on each question. Try to do the best that you can on each question as if it were a real testing scenario. But then before you submit, go back and check your answers against your slides, against your textbook, against your notes, and make sure you've answered them all correctly. And wherever you have trouble, maybe, spend some more time studying that before the exam on Friday. Okay. Someone's asked about seeing the questions for quiz 1. That should be available already. I released the questions and the answers for quiz 1 already. So if you guys are having trouble seeing that, please let me know, because that should have been released as of Monday. And I thank you for letting me know they're open. I'm going to talk about the timing of the tests because they're not going to be limited to 50 minutes. So give me a chance to get through my next couple of slides before you ask about the timing of tests. That's okay. And also for quizzes, these are shorter quizzes. So I would say if you want to match the real timing of a quiz, then the real timing of the quiz is would be for like 20 to 30 minutes. Okay, and somebody's caught me in a pickle here. The quiz 2 is in Respondus, which means you won't be able to open another browser. But you should have probably notes. You should have your textbook, so you can use those kind of hard copy items as you're going through. And I don't actually know what happens if you log out of Respondus and try to get back into Respondus. Has anyone done that? I have it set up so that it's an unlimited time. So you might be able to leave it and come back to it. But I'm not sure. I'm not sure. Okay. All right. Other announcements. You guys have an open homework for Achieve for chapter 3. We are not going to make it through the chapter 3 material, all of it. So that is now going to be due on Wednesday of next week. But keep in mind that numbers 1 through 13 are relevant for exam 1. So if I were you guys, I would try to do those questions in advance of exam 1. And then just a reminder, if you have not completed your participation assignments, there have been 3 so far. you can always turn those in for partial credit. Okay. So regarding Achieve, somebody's asked about the deadlines for Achieve. You can always turn in Achieve late also. There's a 10% flat penalty for questions that you haven't answered by the deadline. So yeah, okay. If you guys end up going into Respondus for the quiz and logging out of it and needing to get back in, just send me an email and I can reset it for you. So hopefully it'll work kind of on your own and we'll find out. Okay, chat box is just blowing my mind. Sorry, I can't keep up. If you guys have things that are personal in nature, like some hiccup with participation, you have to email me about it because there's too many of you guys to handle it here. The participation from last class was due before class today, I believe. So you can always turn these things in late, and if you, just make sure you're just turning it in. Okay, I gotta keep going on my announcements, guys. So for coming into exam one, I wanna take some time to talk about exam one and about the way it's gonna work. The Achieve assignment is no longer due on Friday. It's now due on Wednesday of next week. I've extended that because we're not going to cover the whole thing in class today, but just keep in mind numbers 1 through 13 are relevant for exam one. So, and I'll post these slides. You guys will be able to go through all of these notes, and take your time with everything. I know it's a lot of information. So, okay. All right, exam one. Here's how it's going to work. There will be a window. The exam will become available at 4:00 on Thursday afternoon. And that window will be open for you guys to take it at any point between Thursday afternoon and Saturday at 4:00 p.m. A couple of things to keep in mind here. Beginning at Thursday, 4 p.m., please do not talk to your classmates about the content of this class, right? If you guys are studying in groups and you know that none of you has begun the exam yet, that is fine. But just because in case people have taken the exam, in case people are taking the exam, as soon as this window opens, I want you guys to please, please, please be respectful of your classmates. Don't be putting things in the GroupMe box. Don't be sharing information about what's on the exam or about anything else. Please try to, consider this the same way as you would in a classroom testing situation, where once that exam window begins, cut yourself off from communicating about this class unless you have, a specific small group study session where nobody has touched the exam. Okay. It will cover all of chapters 1 and 2. All of chapters 1 and 2. It will also cover part of chapter 3, not all of chapter 3, and I'll be clear about the content that will versus won't be on it, starting in the next slide. There will be a periodic table link in the instructions for the exam. For those of you who have tried quiz 2, did you guys try to click on the periodic table and did it work? Okay, great. I will put it the same way in the exam as I did. I changed how I accessed it for the instructions this time, so I will use the same way that I did for this quiz when I put it into your exam. Thank you guys for being my guinea pigs. I will also have a calculator provided to you within the Respondus bar. You don't need it. I don't think you're going to need it because the math that you'll be doing is pretty straightforward, simple math. You may, and that we're on the honor system here, you may have a blank sheet of paper with you when you take the exam. And of course, a pen or pencil. Nothing else, okay? Nothing else. Please don't have your phones nearby. Please don't have your textbooks nearby. Take all of that stuff and put it somewhere that's out of temptation's way. I also really strongly recommend that you guys turn off your cell phones while you're taking the exam. It'll help you focus better if your phone's not going off, and it'll reduce temptation. Okay, so in terms of the actual format of the exam, as I've said already, it'll come out in 2 parts. The first part will be multiple choice and fill in the blank, and respondus will be required for this. So everybody should have already checked respondus, or by the end of the day today should have checked respondus because of the quiz. So just make sure that you do that. You will not have a pKa table. So there's a question in the chat box about a pKa table. There will not be a pKa table. I have on a slide from the class that we covered, acids and bases, the benchmark pKa's that I'm asking you guys to know: mineral acids, alcohols, carboxylic acids, and hydrocarbons. And those are the only numbers, those are the only real numbers that I'm asking you guys to know as ballpark numbers. So I'm not going to put up a molecule and ask you what the pKa is, but you need to know kind of comparisons between acids and bases and which is stronger or less strong based on the stability of the conjugate base, based on your first principles. So if there's time, I'll talk more about that at the end, but there will not be a pKa table. Okay, back to my slide. Part 1 is going to be multiple choice, fill in the blank. It's going to be about 25 or 30 questions. You will have 75 minutes to complete part 1. You guys will have more time to complete the same number of questions that you would if you were in a real classroom, because of the time that it takes you to click through, because of the time the pages load and all that kind of stuff. I have accounted for additional time for the different format of the test deployment. And if you have accommodations, those will be already built in. So the instructions may still say 75 minutes, but your timer will be your actual specific timer for your accommodation. For part 2, we will be using uploads. Uploads are going to have to be used for part 2 because there will be free drawing type questions. And so you can't do uploads in respondus, which means part 2 has to be completed in Canvas, but using a regular browser. There's going to be 3 or 4 questions. And I think the 3 or 4 questions should take you guys 20 minutes, no longer than that, to answer these 3 or 4 questions. But because of uploads and people tend to worry about that, stress about that, I'm providing you a whole 10 minutes to take a picture, email it to yourself, and submit it. So you can do whatever way works for you. You can draw it on paper, take a picture with your phone, and email it to yourself, or upload it directly from your phone. You can draw it on your tablet and submit screenshots. Whatever way works for you, as long as the visual answers are there. So any format is accepted as long as it's a format that will work on another computer. Okay, any questions about formatting? I'll get to content on the next slide. So not content questions, but format questions. Are we good with this? Okay, cool. In terms of content, all of chapter 1 and all of chapter 2, as I've said, and hopefully you guys have a good sense of the things that I consider to be more important. Being able to draw Lewis structures, being able to identify formal charges, being able to identify the hybridization of an atom. You guys have seen this type of stuff on your quiz already. Likewise, for chapter 2, you'll see on the quiz that's open now the types of things that I can ask about, but polarity of molecules, the molecular dipole versus bond dipoles, how intermolecular forces impact the boiling point, different acidity measurements, so pKa, or how to predict the equilibrium positions on an acid-base reaction. Also the curved arrow formalism and functional groups. And I just want to remind everybody to review the slides from posted on the 11th, so Friday of last week. Those slides have detailed information about what types of things I want you to know about those functional groups. So make sure you check that out. For chapter 3, we've started on nomenclature already. The only topics from chapter 3 that will be on the exam are going to be in this box, but really they boil down to these key features, which we did last time, and nomenclature, which we started last time and we'll finish today. And something called Newman diagrams, which is a way to visualize torsional strain. So I'll talk about these with the rest of class today. Someone put a question in the chat box about participation. The participation assignments are always located within the slide deck of the class that they go with. So you can see those. If you're ever wondering where that is, open a slide deck that's close to the date of what the assignment is and look for it in there. Okay, so that's the content of exam 1. One more thing that I want to say is that there will be some additional resources coming for you guys. Hopefully I'll have time before my office hours start at 3. If not, then I'll do it soon thereafter. But in the modules, I'm going to be adding another module that's called Exam 1 Prep, chapters 1 through 3. And I'll post in there a set of practice problems that are like the part 2 of the exam. So those will be there for you guys to use as practice problems, and answer keys will be following shortly thereafter. All right, so let's get into science. Woo, science. All right, so as I've said, this dotted line is the break between exam 1 and after exam 1. So it might look like a lot, but really nomenclature is the big thing, and then I'll touch on some of these other topics briefly. So in terms of finishing up nomenclature, which we started on Monday, I just want to remind everyone about these IUPAC names, which are going to be the systematic names that we use to identify molecules. I gave you the overview of these rules for how we're going to name molecules, where first we find the longest chain of carbon atoms, then we figure out how to number the chain, and then we deal with everything that's sticking off from that chain in rule number 3. And as a reminder from Monday also, the overall goal here, the overall overarching goal here is to be able to be unambiguous about how we describe a molecule. So it's a way of naming a molecule so that if I say to you the name of the molecule with words only, you can draw the exact molecule that I'm talking about without any question, without any ambiguity about what that molecule is. So let's go through these kind of one by one. The first rule is finding the longest chain. So that's going to be called the main chain, and that's going to represent the longest chain of consecutive carbon atoms. So in the example that we have up here, that longest chain has 6 carbons in it. And so we're going to have to name that chain based on that 6 carbons. So it gets the prefix of hex. And then of course it gets an ANE because this is a whole chapter about alkanes, right? Notice that it's not just a simple left to right or up down. We have to find the longest chain no matter where it is. And just to remind everybody, each of these are sigma bonds. This whole molecule is connected through sigma bonds. And so each of those bonds can rotate, which means we could rotate these 2 groups, and this CH2, CH3 could be out this direction, and the CH3 methyl group could be up in that direction. So it doesn't matter how the molecule is drawn, you still have to find the longest chain no matter where it is. What happens if you have 2 chains that are the same length within a molecule? So I've got a molecule here with a chain that's highlighted in green that's 7 carbons long, 1, 2, 3, 4, 5, 6, 7. But it turns out that we could have also gone in this direction where we went 1, 2, 3, 4, 5, 6, 7. So how do we know which one is correct? When there's a tie like this, when there's 2 different options for how to number that main chain or how to identify that main chain, what you want to do is count how many substituents there are and take the one that has more substituents. So what do I mean by a substituent? A substituent is anything or any atom or group of atoms that is sticking off of the main chain. And every place where it sticks off, that's a substituent. And if it sticks off from another place, that's a different substituent. So the molecule on the right here, well, it's the same molecule. Let me be clear about that. These are the same molecule. But the main chain that we've identified on the right here has 4 substituents coming off of that chain. If we went with the one on the left, where the main chain is in the green box, kind of shooting off to the right here, then that only has 3 substituents. And doesn't matter how big, how complex, how crazy the substituents are, what you want to do is find the one that has more of them. So the one on the right is the correct chain choice for this molecule. Okay, Next thing we have to do is rule number 2, and that is to number the chain. Every time, so first we have to identify the chain, right? And of course name it, which I guess I should go back to the slide and say, okay, we're gonna name the chain 7 carbons. What's the name of this chain that has 7 carbons?
Heptane.
Heptane, awesome, great job. Yes, this is a heptane. So now that we know, somebody's asked in the chat box, what do I mean by more? Every time you have a group shooting off of the main chain, that counts as a different substituent. So here on the molecule on the right, we have a group over here, a group here, a group here, and a group here, each of them with a different purple bubble around them. So there's 4 different groups shooting off of the main chain that we've identified here. If we take a different main chain, this whole set counts as one thing because it's only connected to the main chain in one spot. So we have 3 kind of purple bubble groups over here. Those 3 groups, there's less of the substituents or the groups coming off of the main chain in the molecule in the version on the left. In the version on the right, there's 4 groups coming off. So that's what I mean by more. Okay, for rule number 2, we've identified the main chain. It's this one that's shown in the green here. It's the 7 carbon main chain. The next thing we have to do is number that chain from one end to the other. But of course, it's a linear chain of carbon atoms. So in every case, every main chain will have 2 options. We can number it this way or this way, right? So how do we choose? And the way that we choose is because we want to number it from the direction that we will run into a substituent first. So what do I mean by that? Let's see the example. In the example on the left, we've numbered it starting from the top and going down. So starting with 1 at the top and ending up with 7 at the bottom. And that means if we follow along the chain, the first time we run into a substituent is at carbon 3. The one on the right, we started at the bottom and numbered it going up to land at 7 on the top. And if we look at that carefully, then that means that the first time that we run into a substituent is on carbon 2. And so you want to choose the chain that has the substituent closest to the end. So that means that this version on the right is the correct version here, where the numbering starts at the bottom so that you have your first substituent at the 2nd carbon instead of at the 3rd carbon. Okay. So after we have the main chain identified and named, it's a heptane. Then we number it. We're numbering it from the bottom going up. Then we're going to move on to rule number 3. And before I switch over to the slide away from here, rule number 3 is basically, what else do we have to do to give this a name? We have to figure out all of the things that are sticking off of it and where they are and put them together in a fashion that makes sense. So you can see that each of these purple bubbles is given a name. If it's a 1 carbon group sticking off, it's a methyl group. If it's a 2 carbon group sticking off, it's an ethyl group. And don't worry about putting them together in order right now. We'll get to that in a later slide. First, let's talk about naming them. So this is going to be naming the substituents coming off of the main chain. These 5 names and structures in this chart here are the first 5 alkanes. And these should look familiar to you from chapter 2 and nomenclature of the functional groups in chapter 2. I've asked you guys to remember the first 10-ish of the simple alkanes, which really means you only have to remember the first 4, which have unusual names, because beginning with number 5, they start with the Greek prefixes. So beginning with 5, it starts with pent, which is the same prefix as like the pentagon. So these hopefully look familiar to you guys. If instead of being a whole molecule by themselves, they're actually attached as a side group or a substituent off of the main chain of another molecule, then they have a very similar base name, but instead of ANE at the end, we're going to drop that and we're going to put in YL. So if it's a 1 carbon group sticking off the side, it'll be methyl. If it's 2 carbon, it'll be ethyl, propyl, butyl, pentyl, and so forth. Notice also, we've had to take off one of our hydrogen atoms to be able to open up that spot to bond it to the main chain of the molecule. So again, these names on the left should be familiar to you guys already from your studying for chapter 2. These groups on the right, these names on the right, should be a natural extension of what you already know. Okay, so when we take this and put it into play with an actual molecule, what we're going to do is give the alkyl group its name, and then we're also going to give it the number of the main chain carbon it's attached to. And when we go to put it together in the actual molecule name, we're going to put them in alphabetical order. So it doesn't matter where on the chain they fall, we will always put an ethyl group in front of a methyl group when we're naming it in the name. Okay, so here are just kind of to show you a little bit more features. These are the same alkyl groups that I had on the last slide, where if you have 1 carbon, it's called methyl, 2 carbons, it's called ethyl. Now, when we get up to 3 carbons, which is a propyl group, it turns out that there's 2 different orientations or 2 different arrangements that we can have those 3 carbons, right? So remember, this is coming off of a main chain. This kind of open-ended bond on this side means that that's where that main chain is. So it can come off in a linear way, which is called just a regular propyl or an N-propyl group, or it can come off and it can branch. And anytime you see this kind of V-shaped branch towards the end of a group, that's considered an iso group. So if it's 3 carbons, this is an isopropyl group. If it's a 4 carbon group, but it has this branching at the end, that's called isobutyl. So again, propyl, prop is for the 3 carbons, and it can be linear as an N-propyl, or it can be branched as an isopropyl. Once we get up to 4 carbons, which is butyl, it can still be linear. It can also be branched at the very end, which is the isobutyl group, or it can be branched closer to the beginning, which is called a sec-butyl group, or it can be even more branched where the branching happens in every direction, and that's called a tert-butyl group. It actually is tert for the word tertiary, which we'll learn about in upcoming chapters, but some people also helps to remember that it's shaped like a T for T-butyl. Okay. This slide is just to drive home the point that I said about iso groups and the iso label being a branch point at the very end of the chain of what's coming off of the main chain. So here's isopropyl. Isobutyl has another carbon, 4 carbons total, but it's still branched at the very end. And if you look over here on the right, isopentyl has 5 carbons now coming off of the main chain, but still branched at the very end. Okay, now that we've named all of our groups and given them numbers, we have to figure out how to put them all in order. And we have to also figure out a lot of times we're going to have a bunch of substituents that are similar to each other. So we're going to learn how to deal with that. And here is, so the T-butyl group again, somebody asked for it in the chat box. The T-butyl group looks like this. So you can see kind of the T function here. So T actually stands for tert, which is short for tertiary, but it's convenient that it happens to be shaped like a T also. Okay, so organizing multiple groups. So keep in mind, we've talked about already, but I'm going to drive home this point here. If we have more than one substituent, we have to put them in alphabetical order. If we have more than one that are the same kind, rather than list them separately, we're going to group them together and give them a prefix on their own that tell us how many there are. And then we still have to say where they are, so we'll still put in a number for each. So with nomenclature, it's the easiest way to do this is to actually see it in action here. So we're going to take our same example that we did before. And if you remember from my other slide and the last couple of slides, each CH3 group is a methyl group. So you have a methyl group on carbon 5, a methyl group on carbon 4, and a methyl group on carbon 2. And we also have an ethyl group, so a 2-carbon unit, coming off of the 3rd carbon. So when we go to name this, of course, we already have decided that our main chain is 7 carbons long, so it's a heptane. The next thing we have to do is alphabetize ethyl and methyl. So ethyl is going to come first before methyl. So we're going to give our name 3-ethyl. And then for the methyls, there are 3 different versions of the methyl. Like they're the same group, but they happen in 3 places. So what we're going to do is give those methyls their own prefix, tri, which means 3, right? So it'll be trimethyl, and then we have to give them the locations, 2, 4, 5. So the methyl groups, there's 3 of them. They happen at the 2, and the 4, and the 5 position. So you can see in the name here how we go about deriving this, right? Heptane is the main chain, and then coming off of the heptane at the 3 position, we have an ethyl group, and then at the 2 position, the 4 position, and the 5 position, we have methyl groups coming off. So let's see some more examples. The ethyl comes before the methyls because they have to go in alphabetical order of the type of group. So we're comparing here the E for ethyl versus the M for methyl. Don't worry about the alphabetization of the prefix. It's the alphabetization of the group. Okay. So here's another example where we can apply our rules. We start by figuring out the main chain. In this case, we have a 6-carbon main chain here. What's the name of this base alkane?
Hexane.
Hexane, awesome. What if we had numbered this 1, 2, 3, 4, 5, 6? Would that have been right? Yes. So it turns out it gets you to the same exact place because this 2-carbon group and this 2-carbon group are identical to each other. So it doesn't matter which way you go, you'll get to the same answer in the end. Okay, so now we have our hexane chain. That was rule 1. Rule 2 is to number it. I've already done that for us. We're going to go left from right. Can you guys see why we should not go right to left here? If we wanted to start at right and number this way, we would not see our first substituent until the 3rd carbon, 1, 2, 3. And so that's not the way to number it. For this molecule, we want to number it from left to right. Keep in mind, it's not always going to be left to right. It's not always going to be up to down. We can rearrange these molecules and how we draw them. So in this particular case, this is the numbering because it gets us the lowest substituent number. Okay, now that we have our 6-carbon chain, now that we have it numbered, the next thing we have to do is identify the groups, right? So here at the 2 position, we have a methyl group, so it's going to be a 2-methyl. The 4 position, we have an ethyl group, so it'll be a 4-ethyl. Then we have to put them together with the base hexane name, and so we do that alphabetically. So the overall name of this molecule, take a moment to think about that for yourself, just a moment. Here's your hint. They have to go in alphabetical order no matter what their number is. And so the name of this molecule is going to be 4-ethyl 2-methyl hexane. Somebody's got their hand raised. Go ahead.
Yeah, I'm just confused on like how to know where you want the substituent to be.
So the substituent is where the substituent is. I'm showing you the molecule, right? And you can't move it around. You can't break bonds or move things around. This is the molecule. So whatever way you number it, there is a carbon bond coming off of the main chain here and one here. Did that reorient your perspective?
Kind of, yeah.
Okay. Somebody else had a question. Go ahead.
I have a question. So why didn't we add methyl-hexane, like 2-dimethylhexane?
Yeah, there's not a second methyl group, right? So here is a methyl group, but this is not a methyl group. This is an ethyl group.
Oh, okay. Thank you.
Yeah. Remember, the whole overall goal here is to be able to unambiguously identify molecules and be able to describe them.
Sorry, quick question about the ethyl group.
Yeah, go ahead.
Does it matter the order of the CH3 or CH2? If it's like in reverse order, it'd still be an ethyl as long as they're paired together?
Well, it has to go this way because of the bond order and the bond connectivity, right? Like because one of the bonds is going to be involved in bonding to the main chain, you could have a CH3 here and then a CH2 because of the octet rule.
Okay, so yeah, you definitely wouldn't see it any other way, so it wouldn't make any sense. Thank you.
Yeah, you're welcome. And so regarding this, if this were the directionality, when I'm talking about the directionality of naming this, I'm only talking about the order of numbering of the main chain, right? The order of numbering of the main chain is important because it helps us identify where the lowest number substituent will be. Okay, and just for kicks, if we wanted to, we can go ahead and do this real quick. If we wanted to try to, on pen, if this were a CH2, CH3, so if these were both ethyls, right? So then this would be a 2-ethyl and a 4-ethyl. And so the name would then be, it would have to be a diethyl, right? Because we have two groups that are identical to each other. So the name would be 2,4-diethyl hexane. Yeah, somebody put it in the chat box. That's exactly right. 2,4-diethyl hexane. Okay. Let's carry on a little bit. This is just to drive home the point and give you another example of if you have multiple versions of the identical group present, how to use the prefixes. So in this case, we have 3 groups that are all methyl groups. All of the substituents coming off of this molecule are methyl groups. So this molecule has a 10 carbon base chain or a main chain. We're numbering it in this case from right to left because that first substituent comes closer to the right end of the chain. Because it has 3 methyl groups, it's going to get a trimethyl designation, but we still have to say where those methyl groups are. So the name for this is going to be 2,5,7-trimethyl decane. Yeah? Okay. Yeah, go ahead.
So I had a question. If, for example, one of these chains were an ethyl group, and you said that it must go in alphabetical order. So if it would be 2 methyls and 1 ethyl group, for example, on this chain, would I put the dimethyl first or the ethyl first?
Okay, so this is a really good question. It's also a very subtle question. You want to alphabetize based on the group name and not how many of them there are. So you would still use ethyl, the E for ethyl versus the M for methyl. Even though there might be a dimethyl and the D would be before the E.
Okay, so I guess I'll just disregard the prefixes.
Yeah.
And alphabetize the groups.
Yeah, alphabetize based on the group. So just keep in mind, you guys, I'm like, there's layers and layers and layers of subtlety of naming these things. The very most important thing is that your name can give an unambiguous answer as to what that molecule is. So if it's something like that, where it's this insane subtlety or like exactly where you put the commas and the dashes, don't worry, you're going to be fine. Okay? Okay. So yeah, somebody put in the chat box. Yeah, the way you decide about numbering this chain is whichever end runs into a substituent first. Hopefully that answers that question. Okay, cool. All right. So in the interest of time, I'm not actually going to go through these sample problems, but I'm putting these up so you guys can see the types of things I might ask you on an exam. So for example, I might say, give the structure of this or that, and then you could draw that thing. I'm going to leave this for you guys to try on your own, and I will post an answer set for these things, maybe not today, but probably tomorrow. I'm also going to skip over, in the interest of time, complex substituents. So we'll come to that a little bit later. We'll return to that after chapter 3, because I really want to make sure that I introduce you guys to Newman diagrams. So Newman diagrams. So we're going to move on from nomenclature, and I want to talk to you guys about some of the key features of alkanes that we can use this new tool called Newman diagrams or Newman projections to understand. So here is the simplest alkane. This is methane, right? It's a C4. Of course, we all know alkanes are only sp3 hybridized. And so we know that all of the angles in methane are 109.5, right? So methane's easy, it's simple, no worries. As soon as we start adding in more atoms and we get to C2, we have ethane. And now we have an interesting situation because all of the carbons are still sp3 hybridized, right? But we have now a carbon-carbon sigma bond that can rotate, right? Of course, in methane, all of those other bonds could rotate too, but you're just spinning hydrogen atoms. But here, when we rotate the sigma bond, we are actually moving these CH bonds relative to each other. So because we have this free rotation around the carbon-carbon sigma bond, we can, now that we have ethane, we're going to see that there is an infinite number of different rotational conformations within this molecule and with every molecule that has more than one carbon. So what do I mean by that? I'm just going to show you two here, two different rotational conformations. In this first one, we have our sigma bond between the two carbons, and our CH bonds are in the plane of the page. These two CH bonds that are pointed up are both in the plane of the page, right? So if we're looking at this in kind of a ball and stick model and we're looking down the axis of this bond, these two CH bonds would be kind of like aligned with each other. But because we have free rotation here, we can hold one side of this steady, take the other side and rotate it just like you would a steering wheel, and move it so that this CH bond that's in the plane of the paper and pointed up is actually rotated so it's in the plane of the paper and pointed down. And what that does, if you look at the ball and stick models down below, that now puts us in a situation where as we look down this bond, the two hydrogens that are in the plane, the same plane as each other, are kind of pointed in opposite directions. And of course, we rotated this kind of 180 degrees, but it can stop at any moment along this turn, right? So as chemists, one of the tools that we have to be able to look at these things, actually, before I go to that, I should point out that this sigma bond can rotate, and it is indeed like constantly rotating, right? So it is constantly rotating, and it has an infinite number of conformations. And I want you guys to think about this for a minute. Are these two conformations identical in their energy and stability? Do you think they're the same? It turns out they're not the same at all. So before we get to that and before we answer that question, I'm going to introduce to you guys this tool for being able to visualize alkane rotational conformers, and that's called a Newman projection or a Newman diagram. What this is basically a different way of drawing a molecule. So instead of using these wedges and dashes, which the wedge means it's coming forward out of the plane and dashes means it's going back, really helpful to be able to look down a particular bond and be able to imagine what orientation the substituents are in for each side of that bond relative to each other. So you can see looking down this bond, we reorient ourselves. So there's a carbon in the front right here, that's the black carbon. And then this big circle represents kind of the electron cloud of that sigma bond that we're looking down. Behind that electron cloud, there's a back carbon back behind there that we can't see. And the way this is drawn, you can see the hydrogen is coming up. And if we're standing in the plane of the screen and looking down it, this dashed line hydrogen that's black is going to be going off to the left and down. And this wedge is coming, that's coming forward out of the screen, will be coming to the right and down. Same thing for the back carbon. There are these pink substituents that go up and left, up and right, and then this one that's in the plane of the screen would be coming straight down. So I'm going to stop there. There will be a question. There will be just one, but there will be one question on the exam about Newman projections. So for chapter 3, it will cover simple nomenclature. I won't do any of the complex substituents for you guys. And it will include these Newman projections. And then we'll pick up after exam 1 with the rest of, with an answer to the question, first of all, about whether these two are identical in stability and why. But yeah, okay. I can't tell, Ariana, if you have your hand up still, if that's new or if that's from before, but I can stick around for a couple of questions.
Do we have a class on Friday?
You do not have class on Friday, so that you guys can use that time either to study or to take the exam.
Thank
If we
you.
want to reach out to you via email, do we just use your, I think it's like K something Belecki at bcu.edu?
Yeah, my email is on the front of every slide deck that's posted. So it's kbelecki@bcu.edu. And you can email me there. And also don't forget, I have office hours today from 3 to 4.
Thank you.
Yep, you're welcome.
Thank you.
You're welcome. Someone's asked in the chat box about a quiz for chapter 3. Don't worry about anything past the exam. Focus on the exam because chapter 3 material will be on exam 1. Someone else has asked for me to repeat which PKA values you should have memorized. I'm going to encourage you to go back and look at that in the slides because I was really clear on that in the slides. That I'm asking you guys to know 4 benchmark areas for 4 different types of compounds. So I'm not asking you to know any specific PKAs for any specific compounds, but 4 different benchmark types of functional groups and their PKAs. So that's all I think definitely intended to be clear in the slides. There's a slide specifically that says, you know, it has the PKA chart. It says you don't need to memorize this. And on the next slide, it says you do need to know these benchmarks. Okay, guys, thank you. I might see some of you guys this afternoon. Don't forget, you have SI sessions also tonight at 5:30. No, tonight at 5. 5 is your SI session tonight in Hibbs Hall, and then tomorrow at 12:30.